Welcome back to This Week in Bevy. This week, Bevy has upgraded to wgpu 24 and enabled unchecked shaders for added performance. The next generation scene and UI system is also making headway with improved spawn APIs and bundle effects. And in the showcases this week, we see a number of landscape and planetary terrain LOD systems with and without voxels. First off, we've got possibly the biggest PR merge of the week. Progress towards BSN continues with 17.521, which is improved spawn APIs and bundle effects. If you've spawned nested hierarchies of entities in Bevy, you've probably done it something like this, with the with children or with child commands. In this PR, a new bundle effect trait has been added in addition to other types, such as spawn and spawn related, that results in the following next generation macro-based hierarchy spawning experience. This is the same example I just showed, but with the new APIs. The order of events when inserting is as follows. First, the bundle is inserted onto the entity. Second, relevant hooks are run for the insertion. Third, relevant observers are run. And fourth, the new bundle effect is run. Notably, these new APIs extend to any arbitrary relationship which was recently merged, not just children or parent and children. Altogether, this new functionality enables spawning hierarchies, lists, and relationships with or without the macro syntax. And also a very interesting development, hierarchies can now be returned from functions. Here we have a button that implements bundle as the return type that spawns a node with some text children. If you're interested in the mechanics of the implementation or you just don't like the macro APIs, definitely go check out the PRs because it lists all of the ways you can use it without using the macros. And next up, building on top of Fallible Systems, observers also receive the ability to fail in 17.731. This means observer functions can now take advantage of the question mark or try operator. And following on Fallible Observers, we've got 17.753, which introduces configurable error handling for Fallible Systems at the global, schedule, and individual system levels. This defines what should happen if you're using a question mark in a system or an observer, and how that error should be reported. For example, whether it should panic or warn. And because of mesh pre-processing, the built-in instance index that's available in shaders in WGSL is not stable and can't be used to reference external data. 17.648 introduces a user-supplied mesh index that can be used for referencing that external data when drawing instance meshes. The shader automatic instancing example has been updated to show this usage. And as of 17.758, which will affect Bevy 0.16's docs when it's released, Bevy's docs will have stylized tags for types that implement notable traits, such as component, resource, and more. You can see a whole bunch of them in a test list here. That's each of these pills right at the top. Now, this is information that is also available in the left-hand sidebar here, but it's a little bit more prominent and a little bit more Bevy specific to see these right at the top. And then we've got a couple of new examples this week. First off, we've got local default values, but without using new types. So while you could new type a value and then implement default for that new type to get a default value, you could also use the get or insert function on a local to set that value if it wasn't set already. 17.710 introduces an entity disabling example. This refers to the default query filter work that can opt entities out of being included in systems. And finally, we've got a new custom render phase example. This uses a custom render phase and some of the lower level Bevy APIs to take the mesh data that's already available, such as this cube, and in this case, draw directly to the view target over it, in this case with a red color. I've taken advantage of this example myself already before it was merged, and it's really nice to see some more of the low level APIs getting documented. So if you're interested in the rendering APIs in Bevy, you're interested in getting a little bit lower, definitely go check this one out. And of course, as always, Alice's merge train is a maintainer level view into active PRs, both those that are merging and those that need work. In her own words, there's a lot of how the sausage is made in these threads, so definitely go check these out if you're interested in how these PRs actually get into Bevy. And we've got a couple of landscape mesh generations in the showcases this week. This one is landscapes that can be created from height maps, now with support for fast dynamic level of details based on quad trees. And back over in 2D land, we've got an asteroid-style ship flying around breaking down other ship-like entities, and also breaking down asteroids. This is Membooster v2. This is version 2 of Membooster, an iOS memory game, which now has a simple card guessing game. Membooster v2 is also working on reintegrating Bevy Velo since they've updated the plugin to Bevy 0.15. And of course, just like that, we're right back into planet-sized mesh generation. This is an Earth-sized planet subdivided down into sub-meter polygons. Meshes subdivide themselves as the player gets closer, and each mesh knows its latitude and longitude, as well as its barycentric coordinates relative to the 20 top-level icosahedral faces, which it will then use to assign itself UVs and heights. This demo is making use of big space, which I've seen in a number of demos like this, especially things related to planets and space and very large distances, so a worthy crate to look out for. Next up, we've got a view into Noumenal's main shader, now with hybrid ray tracing. The shader computes everything from primitive surface data stored in storage buffers and screen coordinates. And just a heads up, there's a bit of a flashing warning for this planet as it comes in, and we're right back into full-size voxel planet projects. Updates to this full-size voxel planet project include placing the planets on different voxel grids, which allows to move the planets without actually changing the voxels. And you can see as the camera gets closer, you get more detail, all the way down to the surface before you can see what, gives off a lunar surface vibe because of the shading. And of course, from 3D back to 2D again, this is Verlet integration. Verlet integration is a numerical method used to integrate Newton's equations of motion. This demo uses it to create a web slinging effect, as you can see here. If you want to learn more about Verlet and game applications, there's a great GDC talk called Math for Game Programmers Building a Better Jump that covers some of these integration techniques. And next up, we've got procedural dungeon mesh generation, which is, as I said, mesh generation for a procedural dungeon. There are multiple floors shown here, which will eventually be connected by a staircase. And honestly, it's always really nice to see gizmos used in this capacity, but maybe that's just because I have a special place in my heart for development tools. And next up, we've got Flappy, which is a Bevy 0.15 Flappy Bird implementation that is also deployed on the web to play and open source for educational purposes. So if you're interested, we've got the link to the source repo and the web deployment over on the This Week in Bevy website. And that brings us right into the crates with Bevy picking BVH backend. Bevy picking BVH backend is an optimization, or intended to be an optimization, to mesh picking using a BVH tree. BVH is a bounding volume hierarchy, and as I understand it, throughout the week this actually got multiple backend support for different bounding volume hierarchy implementations. Now my understanding is also that there are no benchmarks currently, but the creator of the crate has seen some benefit to very large scenes. And then we've got haalka v3, or v0.3 anyway. Haalka is an ergonomic reactivity library powered by FRP signals using the Futures Signals crate. It is a port of the web UI libraries Moon, Zune, and Dominator, and offers the same signal semantics as a thin layer on top of Bevy UI. While haalka is primarily targeted at UI and provides high-level UI abstractions, its core abstraction can be used to manage signals-powered reactivity for any entity, not just Bevy UI nodes. There are also some really great examples in here, such as a Minecraft inventory menu that are definitely worth checking out. And then we've got Bevy Web Server. This is the first release of Bevy Web Server, which is a web server integration that allows you to easily append a web server to Bevy. It supports creating standalone apps or appending a web server to an existing Bevy app or game. And you can see the example here using Axum. Another new crate, Bevy Easy Database. Bevy Easy Database is a persistent storage solution that automatically serializes and persists your components to disk using Fjall as the underlying database. It supports automatic persistence, hot reloading of component data, and selective persistence using marker components. And last up, we've got Bevy Tailwind v0.2.3. Bevy Tailwind brings Tailwind's classes to Bevy, generating nodes from a TW macro, as you can see here, both the input code as well as the compiled code. And that's it for this week. As always, we've got all of the pull requests that were merged listed on the website. If you want to make your way through the entire list, there were a bunch of rendering fixes and PRs and performance improvements this week that we didn't mention. So if you're interested in the minutia of rendering, definitely go check that out. And I'll see you next week.